Hi, today we're gonna cover value at risk as market risk function. So, value at risk defines a probability that a return is less than a given threshold over a specific time period. Generally, we calculate 99% weekly VAR, 95% monthly VAR. Monthly and weekly is the holding period of the portfolio. In other words, so what is a magical number, or it's a number which actually depicts the market risk of a portfolio. So entire risk is depicted by one number. So in this example, we have this bell-shaped curve you can think of, and here the returns are represented by this curve. In this example, there is a portfolio of 150 million which has a VAR of 5 million, and it's at the 5% probability level and the holding period of 1 month. So what does it mean? So what we're really saying is over that month there is a 5% probability that the portfolio could lose more than 5 million, right hand side, or we can say that there is 95% chances the losses will be less than 5 million. So we can even explain it uh, by saying it on the right hand side, which is over the month there's a 5% probability the portfolio might lose more than 5 million, or we can say it other way, using the left hand side portion of the curve, saying that there's a 95% chance that losses will be less than 5 million. There are a few drawbacks of this methodology or VAR. It doesn't provide the maximum magnitude of loss that could, but only provide a probability of given amount of loss. So it says, like, it talks in probability terms and amount terms, but it doesn't say what the maximum loss can happen, because it's only talking about 95%. But what if our losses are more, and they will be more at the 100% level or 99% level, because those are not explained by value at risk number. VAR doesn't take account the relative liquidity of different risk positions. VAR doesn't measure the counterparty credit risk like regulatory risk, operational risk, which we talked in last slides. Due to various VAR calculation methodologies and subjective inputs to the model, making it difficult to compare risks with other portfolios. So, if we have a bad input, subjective inputs, obviously the model results will come out bad, and you cannot do the comparison with other portfolios. VAR can only be calculated for the products which are actively traded and their historic prices are known. So what we're seeing here is a very simplistic example, but in the real case, a portfolio is comprised of many instruments. Like sometimes portfolio may have equity and fixed income. They have their own risk factors, and pricing them based on risk factors and calculating VAR is not that easy, and based on historical um, price may not indicate what will happen in future. So um, first of all, you should know the price of these instruments. Sometimes the portfolio may have certain positions for which you don't even know the price, so you cannot produce the VAR number for those. There are three major approaches to calculate VAR. First one, which is a very famous one, is a variance and covariance approach. It is also called parametric and analytic approach. There are few assumptions. Investment returns are normally distributed and serially independent. So that's a basic assumption of this method. Portfolio return distribution can be calculated using modern portfolio theory, mean variance frontier theory, which we studied in past. 1 day holding period is used to calculate the return to measure VAR. So the holding period is defined as 1 day. So it's a very simple formula. You can say the portfolio value multiplied by expected return Z value. So if you are calculating the 5% VAR, so it will be like at 95% intervals, it will be like 1.65 and standard deviation of the portfolio. So for an example, um, if I have a portfolio of 500,000 and my expected return is 5% of this portfolio, and we are calculating at 95 percentile VAR. So this represents the 5% probability. It's a Z value corresponding to that, and standard deviation is 10%. We solve this, this will come out as 11.5 negative percent. And if we solve this equation, the number will come out around 57,500. So this is 95% VAR using variance covariance method. All right. Advantage: VAR calculation is straightforward, easy to understand, no need of computational power. Computation simple, no need to value each asset in portfolio as long as we know variance of assets, covariance between assets, and risk factors. Uh, we can plug it into formula and calculate them. Can be applied for the different time periods, short, long period. There are certain disadvantages. Basic assumption is normal distribution of return. Sometimes for for derivatives, the return may not be normal distributed, so we cannot use this method if the return of assets is not normal distributed. Analysts need to know the variance of every asset and the correlation between them. So these values are hard to compute for the large portfolio. So we know when we compute covariance, number of inputs are large. We need variance of individual assets and covariance between them. So as you can see, as number of securities they grow in a portfolio, so computing correlation between them will be very computation intensive because there are so many inputs to be considered. Inputs are calculated based on historical return of assets, as we said in the last presentation. The history based return are not guaranteed for the future return. So we cannot say what happened in the past will continue happening in future. May not accurately predict the future. Assets with option returns are not normally distributed, so their VAR cannot be calculated under this method. The second method is historical method. In this method, we rank historical returns from highest to lowest and pick the lowest 5% to calculate 95% VAR. So in this case, you can see we have to an example from Investopedia where this ticker returns are sorted, and you can see the, the minimum is 9 minus 9% and maximum is 15%. One of the advantages of this method is non-parametric, which means the assets return doesn't have to be normally distributed. So In this case, we just sorted the return, created a distribution of return, and we just picked the uh, uh, pick the lowest 5% value. So in this case, the 5% value lies between minus 400 to minus 800. So that value will be our var value. Advantage: it's easy to calculate and understand. Doesn't assume the return distribution as opposed to normal distribution assumed by variance and covariance approach. It can be applied in smaller and longer periods of time. Non-parametric feature: the historical returns requires minimal probability distribution compared as other methods. So in this case, we have no assumption whether it's a normal curve or some other distribution. So it has a minimum set of assumptions. Disadvantages: large database of historical returns are needed for the calculation, and it assumes the normal distribution of return in future will be same as past. So certain disadvantages are common with the other method. Here's the last one, which is the most famous one, and we require a sophisticated compute modern IT system to do these simulations. By using distribution of inputs, thousands of possible outcomes are calculated based on statistical simulation, and var is derived from these outcomes. So to compute var, obviously there are lot many inputs, there are lot many assumptions, there are risk factors, and the distribution of those inputs are created in case of Monte Carlo simulation, and their outcomes are predicted by doing the that statistical simulation, and then what is derived from those outcomes. Advantage is flexibility, more flexible than other methods because analysts can specify valuation models and probability distribution of every input parameters. These parameters don't have to be based on historical data as they can be analyst future expectation. So what we saw it in last two methods, we were using historical data, but with this Monte Carlo simulation, analyst can have its own expectation about the future. It can use it in this simulation. Non-parametric, it can be used to compute for assets with options because we don't have a normal distribution assumption. So option return, even though it's non-parametric, it can be used in calculating var. It can be used to generate more the outlier probabilities, disaster scenarios than statistical method would. There are many disadvantages. It requires identifying key risk factors that impact each and every securities held in the portfolio. Of course, those are key input, and coming up distribution of those risk factors is not easy. It's computational intensive. It requires mathematical modeling capability. Output is as good as model inputs, garbage in, garbage out. Model output is dependent on valuation methods like Black-Scholes, Smart, and so we saw these. So if the models if these models are not correctly implemented, then we may have a bad output from this model. The var, there are different flavors of the var, and the var value should also test it with the backtesting of var. Backtesting means the var results are checked against the actual market prices or the var is kind of prediction, and it should be measured against the actual outcome so that we know how the model is performing, so that this model can be fine-tuned. That method is called backtesting. IVAR, incremental var, so it's just checking the var values by adding another security in the portfolio. CFVAR is a cash flow at risk. Instead of using var, we substitute cash flow. EVAR instead of using var, earnings are instead of using value in var, earnings are substituted. Tail value of risk T var is the var plus average of the outcomes in the tail beyond the percentile. So we're talking about 95%. So if we take var up like beyond 95%, up to 100%, we just take average of those values and add it to var. V car is a credit var risk due to credit events. We'll explain later. And stress testing is also a methodology which we discussed later. It can be used along with var calculation. Thank you.